Hello and welcome to yet another episode of Tetrate Tech Talks. Thank you for joining us. Today is Friday, July the 1st, 2022. And my name is Eitan Suez, and I'd like to welcome you to the Tetrate Tech Talks, which is a weekly live stream where we feature conversations with guests and discuss technology and do technical demonstrations and more, specifically around service meshes. Tetrate is the enterprise service mesh company, and much of our focus is on technologies such as Istio, Envoy, Kubernetes, and much more. But we don't shy away from going further afield. So I'd like to welcome you. If you're with us live, feel free to please say hello in the comments. Tell us, where you're joining from. We're happy to have you. Okay, and as usual, we'd like to begin our episode with sort of going through our sort of agenda and letting our Tetrate Tech Talks landing page be our guide. So this landing page is, the URL for it is in the description to the episode, but it's also flashing here up on the screen. And I'll make myself just a little bit smaller here so you can maybe see it better. And maybe we'll delve right into our outline here. All right, so as I mentioned, the Tetrate Tech Talks are a series of broadcasts that we run every Friday, usually at 9 a.m. Pacific, 11 a.m. Eastern, or noon Eastern, 11 a.m. Central. I come to you from Central Time Zone. I'm in Austin, Texas, and I'd like to welcome you. Okay, so the objectives of the Tech Talks are obviously to learn and share knowledge around these technologies and to get to know also the people behind them, behind the service mesh community, and above all, to have fun in the process. Today sometimes we do a combination of guests and tech demos. We've had a variety of interviews in the last couple of episodes, and so today will be more of a technical demonstration. I am your host, Eitan Suez, and just before we get started, I'd like to sort of do a recap of last couple of episodes. So last week we had the pleasure of having with us Josh Long. If you're a Spring fan, you know who Josh Long is. But if you're not, if you're in maybe a different tech stack, Josh Long is a technology advocate for the Spring framework, which is an open source framework. And the week before, we had the immense pleasure of also having Kelsey Hightower. I can't believe I managed to steal a couple hours of their busy schedule. Both of these folks are very, very busy, and we've had a wonderful 1 hour long conversation with each of them. So if you've missed those episodes, just head over maybe after this one to the YouTube playlist, and you can find the recording. It's right there for you. All right, on to our episode today. I'd like to begin by talking about how this came about. And I don't know if many of you know this, some of you might, that the Tetrate Tech Talks started around April. I think April 1st was our first episode. But prior to the Tech Talks, Tetrate used to have another sort of a monthly or recurring series of video episodes named Istio Weekly. Right, and I can show you the Istio Weekly playlist, which is right over here on YouTube, and there's a good solid 17 hours of content there. A lot of stuff, really interesting stuff to help you sort of ramp up with the technology. But we recently had a message from Machi, whom I'd like to give a shout out to. Machi, he made a suggestion on the Tetrate community Slack. He said, I watched episode 12 and I loved it. It was an interview with Aditya, who is both a Tetrand and a committer to the Istio project. And counter to intuition, perhaps, what we discovered regarding Aditya is he tried to learn Istio by reading the documentation. But for him, that wasn't really the optimal path to learning. And for him, the optimal path to learning was actually checking out the code base and reading the code and familiarizing himself with the code and the tests, and maybe writing some tests, running tests, and little by little sort of wrapping his mind around these concepts and how Istio actually functioned, which is definitely another way of going about and doing things. And so Maciej said a couple of weeks ago, I think it was, he said, "Hey, why don't we take his advice? Why don't we? We've done a bunch of episodes in the past about basically how to use Istio. We've done onboarding VMs, installing Istio, doing upgrades, more from the operator's persona point of view of using the or maybe the developer's persona of actually deploying some microservice application to the mesh. Why don't we do the other way? Why don't we learn it from the inside?" And I thought that was a terrific idea. And so this episode was born, and this is in my mind going to be one or maybe the first in the series. Okay, so this is not the end of the road. Oh, and Machi is with us. Hey, Machi. I'm gonna put you up on screen here. Thanks for joining us. All right, so this episode is for you and all of those out there who want to really maybe get deeper into the technology and really understand how it works. And so this episode is the first in what I contemplate will be a series of episodes that will explore Istio from the inside. And I took the liberty to go ahead and pre-record a demonstration that we're going to begin in just a minute or so that will walk you through the most important prerequisite step, which is how do you set up for local development with Istio with the code base. And so without further ado, what I'm going to do is I'm going to sort of disappear myself and show you a recording that I made just a couple of days ago that will walk you through exactly how you set up for local development with Istio and get to a point where you could start studying the code, running the tests, and so on. So here we go. Hello and welcome. Eitan here with Tetrate. The subject of this talk is local Istio development. And the question that I essentially am asking is, how do I set up my local machine to work with the Istio code base so that I can learn how it functions from the inside? So we're not going to really delve into the code base. This is a preparatory step that's going to essentially get us to a point where we can work with the code base effectively on a local workstation. So here I am on my local, this is an Ubuntu workstation. And the first thing I suppose we should concern ourselves with is, how do we get the code base? Where do we get the code from? And this is the repository for Istio. This is, I should mention, the primary repository for Istio. There are a number of repositories, and the one labeled Istio/Istio is the one you want. And definitely read through the README, which will orient you to this particular repository and where to find information. It's really well done. So definitely make sure you do that. So I've already checked out this code. I have a workspace folder and inside it an Istio folder, and I can show you that I've just cloned this repository. Now, if you're, I suppose, wanting to set up in such a way that you can contribute pull requests, you might want to first consider forking the repo to your own space and then cloning that. But in this case, this is just a demonstration on getting set up. I don't have an intention of committing code to this repo, just mostly using it. All right, so here's the code. There's a bunch of code in here. And a lot of folders, and it's hard to sort of make sense of it. But one thing that I want to sort of do with you is just show you a kind of a directory tree of maybe not the current directory, but the package folder, which contains the source code. And so you can kind of get an idea for the variety of packages or subdirectories that contain code in this code base. There's a lot of it. So that'll be maybe a subject of future episodes, is digging into different areas and understanding how they work. All right, so you've got code, and the idea now is, or the thought is, well, what do I do? How do I get this all built? How do I build this code? How do I install my own, perhaps, version of Istio using my own copy of the code? And many of those questions are answered by the Istio wiki. So you should know that the wiki is present, and you should take the time to familiarize yourself with these files. I'm going to call out a couple. One is preparing for development. There's one for Linux and one for Mac that begin to sort of walk you through some of the dependencies that you're going to need. So you're going to need Docker. I have Docker installed. You're going to need make. And perhaps the first command you might run once you check out the code is make help, which will show you some of the build targets in the description. So we'll get back to that in just a minute.
Obviously, you need Git. You might want to set up a Kubernetes cluster somewhere. The idea here is to maybe set everything up locally. And there's some environment variables involved and so on. There's a whole list of things you might want to consider or go through as you set up. Another important page that you want to know and familiarize yourself with is using the code base. And that will walk you through some basics, like how do I build the code? What's the make target for that? So relatively straightforward, right? And here, the output of make help tells me that make build will build all the binaries from the Go code. So you need to have Golang installed. I guess that goes without say. And I'm building the code now. This, if you do it for the first time, will take probably several minutes. This is going to be mostly a no-op for me since I've built this code already before. This shouldn't take very long. Actually, I'm surprised that it's taking this long. All right, so we'll carry on while we wait for this code to build. There we go. Not yet, almost. All right, it tells us how long it took and so on. So great. So I've built my code. What does that mean? That means that in a folder called out, you will see for a particular machine architecture, in this case x86, we have all our binaries. Let me pull that up and show it to you up at the top of the screen. And so it's not a bad idea to kind of get a little bit of a lay of the land. What binaries exactly were built? There's the Istio CLI right there. There's the pilot discovery, which is istiod is used is run with this binary, and the pilot agent, which bootstraps Envoy, are some that we can call out here. And notice Envoy's there, and there are other binaries and artifacts as well. So that all got built. And then the next question we should ask ourselves is, what do we do now? What if our objective is to install Istio, our own custom-built Istio? What's the next step? And the next step is typically to build the Docker images, which are the inputs to all of the deployments that take place when you install Istio. So that would be the make Docker target, which you see it there in the middle of the screen, build all Docker images. And then subsequently, you push those images to a repository or a Docker registry, rather, which then enables you to then install Istio onto a Kubernetes cluster, and you can actually tell Istio Cuddle CLI where to obtain your images from through. And that's not a bad thing to talk about next. So if you look, I have a couple of environment variables. One is called hub, and one is called tag. And by setting those, you can use those in conjunction with the Istio Cuddle install command to then install Istio by using the images you built and published to whatever Docker registry you specify in this hub environment variable. And the tag is it basically governs the image tag that is used when building images and sort of stamping those on the images. All right, so I'm not going to actually run make Docker right here and wait for all that to finish. It's not too long an operation, but still I want to save you some time and talk about things that are material. I've run make Docker. I've run make docker.push, and I suppose we could look at my local Docker images. Let's see if that works. Yeah, so this is the image tag that I selected, and here you see images have been built and published to localhost 5001. So what is localhost 5001? I have a local registry running. How did I set this up? To learn a little bit more about that, I want to bring up one more resource that you guys should look at, which is from which I learned a great deal, which is called Local Istio Development, which this resource accompanies a talk that was given at IstioCon 2021 called Local Istio Development. There are the slides for it. You can follow and look at the video. It's about a 10 to 15 minute recording, whereby John Howard, who's a committer on the Istio project, discusses different ways of setting up for local development that could save you a lot of time. But there's always trade-offs. Because sometimes when you take shortcuts, you might end up with a configuration that less and less resembles what you have running in production. So he brings that up. But notice that he's doing a similar thing to what we talked about, setting a hub and a tag and calling make docker.push or dockerx.pushx is a variant of that. And then using Istio Cuddle to install something to a Kubernetes cluster. So we need a Kubernetes cluster. And I believe here, John recommends a variety of local Kubernetes clusters you can work with. I decided to go with Kind. I'm familiar with Kind. It's lightweight. It works really well. Kind stands for Kubernetes and Docker. And if you're not familiar with it, you will very quickly can become familiar with it by just reading the quick start and the user guide. And what I will recommend you do is you follow the instructions to set up a Kind cluster with a local registry. They give you the script, which I've gone ahead and copied to my local machine. I called it Kind with local registry. And this will basically stand up a Kind cluster for me with a local registry. And you can see if I do a Docker PS, you can see that registry :2 is my local running registry, which is available on localhost 5001. And then I've got a Kind cluster. There it is. And so my kube context is already set up, my kube config, kconfig get context. Yeah, and I can do a kubectl get namespaces, and there are my namespaces. So I've got my Kubernetes cluster, I've got my local registry, my images are built, and now we're ready for what I like to call the coup de grace, which is the final command, which will install Istio on my local cluster. And so since we've built our istioctl binary, it's in the out folder, we can just invoke it with the install subcommand, and we can set our hub and our tag. I've chosen to use the minimal profile just to make it quick and simple. And we can run this command and install Istio. Notice it says version 115, and that's because at this particular point in time, version 114.1's already been released. I've checked out the code from the master branch, which basically means that the next major version is going to be released is going to be 115. All right, so let's go through and verify whether we have a functioning Istio mesh, right? We can look at our namespaces. There's Istio system. That's a good sign, right? We can look at the pods in Istio system. And istiod is there. That's a great sign. And then we can go further and describe in the Istio system namespace the pod istiod. And we should be able to verify that the containers have the right images, right? With the image you can see there, it says image localhost 5001 pilot : with my tag. So it looks like it's using my deployment of Istio, which is exactly what I wanted. And the pod is running, so that's a good sign. And then we could basically put it through its paces. We've got a samples directory right there. That's part of the Istio repo. I'm sure many of you are already familiar with it. And the book info sample and the hello world sample, we can deploy hello world and test that it works, right? So k-apply-f hello samples hello world. And likewise, I like to apply also a client container, namely the sleep app. And we can look at our pods and we can see, yeah, of course, I forgot to label my default namespace. So let's try again, k-delete-f. And k-label, namespace default with Istio injection, right? Without that, the magic won't happen. So let's apply-f one more time. K-apply-f sleep. All right, so we should see now that we have new pods coming up that are running, that have 2 containers each, and that's the important bit. So that means that sidecar injection is working. And then the final test is basically doing an execution from the sleep pod to verify that if we call the hello world service, it will load balance between v1 and v2. So let's try that real quick. Hello world on port 5000, hello. All right, so v2, and we should get a v1 as well. There we go. All right, so that all works. So this is a pretty good place we're in. We've got the code locally on our machine that we can inspect. We can even bring it up in an IDE. I failed to mention that. And there's a choice of IDEs for Golang. But all I did here, I'm using Goland, which is an IntelliJ product, which I'm rather familiar with JetBrains IDEs. So that was my choice. And all I did was create a project from existing sources. I pointed it at the directory in my workspace called Istio, and it slurped up the code. I think I had to set up my Go version. It was just a prompt, and then everything sort of worked from there. So we can look at the code, which is great. And we've got the code built, and we've packaged it. and we've deployed it, and it's running and it's working, right? So where do we go from here? And if we go back to John Howard's page here, he talks about how it's important when you're working locally to have a really productive sort of development loop, a feedback cycle, right? From being able to make a change to the code to seeing that change actually manifested in the running Istio installation, and how there are ways to sort of cut out some laborious steps. And namely, I'm looking at this whole process of having to build the code, but also package it in a Docker image, and then publish those images, and then go through the installation process again. Maybe we can cut that out. And there's a conversation about a way of doing it, a particular configuration, which I think makes a lot of sense, which I'm going to recommend, which the idea that maybe we can run istiod out of the Kubernetes cluster, but the rest of the Istio system in the cluster. And so in order to do that, let's think about what would be required. I mean, I suppose we can not just imagine, but let's actually delete istiod, right? If we look at the pods in the Istio system namespace, we can get rid of that, right? Delete deployment Istio system istiod. Now, obviously, now I've got to replace it with local running Istio. And the next question that comes to mind then is, if I run Istio locally, first of all, how do I do that? And that is just a matter of doing a go run on the binary called pilot discovery with the argument discovery. So that's easy enough. And what we learn is that when we run istiod locally, if your kube config file is, or your context is set up to talk to a particular Kubernetes cluster, so will istiod. That's how it'll find the kube API server that it will talk to. So that's great. But you've got to also take into account the fact that you need to establish bi-directional communication between istiod and the other sort of components it talks to, and that's namely the pilot agent and the sidecars that are on the cluster. How do they talk to istiod? They usually try to reach the Istio service, right? So if we look at the service called istiod, that service is designed through a selector to look for pods matching these labels. And we don't want to run istiod as a pod. So we're going to doctor things up. And this is exactly what John is proposing here. He says, let's delete that service and set it up again and delete its endpoints and set it up again, but this time not use a selector. Instead, we can explicitly set the endpoints to point to the IP address of your locally running istiod outside of the cluster by determining the IP address of your local machine from the point of view by looking at the Docker 0 interface, so to speak, of your network interfaces list. So if you do an IP route grep Docker 0, this IP address is essentially a way for code running inside a container inside your Kubernetes cluster to talk to code running on your local machine. And so notice what he does in this script is he actually injects that IP address as the address of the endpoints object for the istiod service. So this is something that I wasn't actually familiar with, that I'm so used to using a service with a selector, but you can set up a service without a selector and explicitly design or designate its endpoints by defining an endpoints object with the same name as the service in question. So I've got this script. I copied it locally. There it is. And I'm just going to run it. I'm going to say use local pilot. And that's going to delete my existing service, create a new one. And we can look at that service now. And notice it doesn't have a selector. And if I look at the endpoints in that namespace, notice the istiod endpoints all use the same IP address that we extracted from that Docker 0 interface. So the big question now is, well, if we run Istio locally, will our system continue to function, right? So I like to, first of all, clean up my whatever I had originally deployed, hello world and sleep, and repeat my experiment. So I'm going to start istiod, and that's simple enough to do. I can basically do something like this, pilot discovery with a discovery argument, and that will run it. Right, and now we can k-apply -f samples hello world.yaml. And what I expect to see is the istiod spring into action and configure my sidecars, right? So if I just press enter here, you could see in the top panel that a whole bunch of pushes of new configuration for the hello world endpoints was sent to my sidecars. So that's a great sign that everything is working. And so that's terrific. So what does this buy us? Well, for one thing, we can modify the code now without having to bother repackaging these Docker images and reinstalling Istio. We can just run istiod locally, which is terrific. And then this also allows us to do things in debug mode inside an IDE. So let's do that next. Let's go to my IDE and find the location in the code, and that would be pilot command, pilot discovery. There's main.go. If we run this thing, now we need to modify the run configuration to make sure that the program argument discovery is passed into it. But once we do that, we can run it, and then we can run istiod from our local. So I called that run configuration istiod. There it is. And I can run it in debug mode by just clicking on this little bug. And notice in the bottom here, things are compiling, right? So we should end up with a running istiod, but this time in debug mode, which will allow us to put breakpoints in our code, which is the next subject that I want to bring up. So I've looked through the code and I found a rather apropos location under pilot package service registry kube controller. There's an endpoint controller. And in this endpoint controller, notice that istiod is coming up. That's terrific. There is this function called process endpoint event, which is essentially a callback. That is when an endpoint is published to my Kubernetes cluster. Yes, when it's provisioned, rather. Istio is a controller, essentially. It has controllers that have hooks there. They're actually notified by the Kube API server when new endpoints are created. So process endpoint event could be the creation of an endpoint. It could be a deletion of an endpoint, the update of an endpoint. And Istio needs to be in that loop because it builds a service registry. And it also needs to update the sidecar configurations and push them to the sidecars. So we can put a breakpoint in here. And as we put our breakpoint, we can maybe deploy the sleep pod. And we should see the creation of that endpoint trigger this particular function. And sure enough, it does. And if we look at the bottom here, notice the parameters that are being passed to this function. The name of the endpoint is sleep in the default namespace. So that's exactly what we expected. And the event is an event add. There are also event updates that happened. And looking through this code, I came to realize that there are a variety of concerns when an endpoint is created. Is the endpoint ready to take on traffic? And if it's not, maybe it's not time yet to add it to the service registry or to publish its information to the sidecars because it's not available yet. And there's other concerns like, I think if you've read a lot about Istio, you understand that there are some things that Istio does, namely debouncing and batching of events so that the sidecars are not updated too frequently. That happens as well. But we can step into this function, right, with an F7, and we can walk through this code and in the process gain an understanding of what this function does, which is exactly the point, right? So this is actually, I think, a good point to pause and recognize that we've essentially established our objective, which is to have a local setup with the code that we can run locally with minimal amount of churn and put breakpoints in the code. And as different events happen, we can actually follow those events and try to get an understanding of what's happening in the code. So I'm going to resume processing this code, and I suppose the last thing I want to leave you with is the following. The objective, remember, is to learn the Istio codebase. And the thing to realize is you don't necessarily have to have a completely running environment in order to do that. There's too much code. And what you want to do is have some kind of divide and conquer strategy. And the way to do it is from the bottom up, from the simplest piece of code, by exercising the tests. So by reading the tests, understanding what they do, what methods or functions that they exercise, and their expectation of the behavior of those functions, we gain the understanding we're seeking. And so I'm going to leave you with one last exercise, which is I found a very, very simple piece of code, which might not be a bad place to start, um, which is about SPIFFE identity, right? So there is a file somewhere under package SPIFFE. Let's see if we can find it here. With a very simple function called parse identity. There's an identity struct here that defines the SPIFFE identity. Remember, the SPIFFE URL is a trust domain like cluster.local with a namespace and a service account that can be parsed into from a string from the URL to these particular pieces. And that's essentially what this function does. It uses a string.split function to split based on a slash, and then extracts the various parts and puts them in the right places inside that struct. And we could look or locate a test for this function. And sure enough, there is a SPIFFE test file. And if we look at the sort of structure of this file, notice there's a test identity function here that has a variety of test cases with some input and expected output. So the input here is some SPIFFE URL, and the expected output is that each of the parts was parsed accordingly. And we can run this test by simply clicking on run there. And maybe I'll stop istiod while this is running, and our test is running, and our test is passed. And we can run all the tests. There are multiple test cases here, and we can see them all run and passing. And we can maybe show all passing tests here on our little nav bar on the left. So you can study these test cases and gain an understanding of exactly how this function behaves. And you can repeat that over and over again for other parts of the code to really understand how this works. I think the challenge is the fact that Istio is a very, very large project with many, many tests, and it's going to take some time. All right. Well, thank you for your time. I hope you found this useful, and we'll see you in an upcoming episode.
Okay. All right. Well, thank you, Eitan from the past. That was terrific, if I may say so. Guys, I hope this was useful as a first step to get your environment set up to where you can study the code. Now, this, needless to say, opens the door to subsequent episodes. I think we need to go further and go deeper. And right now, I have some thoughts circulating about maybe inviting Aditya back to do a demo for us if he's got the time and inclination, or maybe some other Tetrand or someone from the community to come on and give us a demo. But that's the basic idea. I hope this video can help you if you're stuck and you're trying to get your environment set up. So those resources, by the way, you should know, are collected not just in the video, but also on our landing page here. So if you want to quickly hop on to that using the codebase wiki page from the Istio repository, that link is there, and John Howard's session from IstioCon 2021 is there too. If you're curious about trying out the Golang IDE, there's the link, and then maybe a little bit of homework, right? So now that you're, hopefully you're set up with your IDE, you're going to start looking at some tests, and that takes you to a world where different new skill sets you're going to have to develop, right? So obviously you'll need to be comfortable with the Go programming language. There are plenty of resources to learn Go out there, books and websites and so on, and playgrounds and blog entries, and just consume them all, right? But there's obviously the sub niche category of learning how to do tests, automated tests with Go. So obviously you want to become familiar with Go testing libraries, and I put a couple of links there. So there's you'll come across tests, at least unit tests, that don't really in the definition of a unit test is you don't stand up the world, right? You don't start an HTTP server just to test how a method works, and there are some libraries that help you with that. So you'll come across things like HTTP test, which is a Golang helper for calling HTTP server handler methods that help you sort of record the response of calling those methods and construct the HTTP request and response writer objects necessary to invoke that handler function. And also you'll come across references to GoMega. GoMega is the BDD testing framework. I think behavior-driven development, ways of expressing assertions that are very readable and very easy to understand. And so you'll come across that as well in the code base. And there's much more that we need to discuss. And so we'll leave that to to perhaps some subsequent episodes. Gosh, I think that covers pretty much everything I wanted to cover for today. Let's just see where we're going. Maybe I'll wrap up the episode. And so in terms of upcoming episodes, next week, we take a different attack. Hey, Moz, thanks for joining. I appreciate you saying hello in the comments. Welcome. We're going to sort of switch gears next week and talk to a fellow Tetrant. His name is Lee Huang. He's based out of Canada, and he works for Tetrate's customer success team. And so we're going to discover with him the things that he does and how he works with service meshes and with clients. And we'll maybe also talk about the Tetrate Service Bridge, which is our enterprise product that I'm sure that he works with as well. I think Lee has a unique perspective on the technology and specifically as it relates to how working with networking has sort of evolved over the years. Also, I'd like to mention, as I always do, if you've recently taken your Kubernetes certifications and you're thinking to sort of distinguish yourself further, you're ready for another challenge, perhaps, you should know that Tetrate has its own Istio certification exam by the name of the Certified Istio Administrator by Tetrate, which is a mouthful, and that's why we usually use the acronym CIAT. But we have a past episode with Peter from about 3-4 weeks ago where we walk you through how to prep for it. So you might want to consult that episode and consider maybe taking that certification exam. And again, the idea for this episode came from a suggestion on our Tetrate community Slack. So I invite you to join us on the Tetrate community. The invite URL is right there on our landing page for every single episode at the very bottom of the page, as you see here. And that will basically get you in. We've got a variety of channels that are dedicated to different things, such as some of the workshops that we run and the certification exam, and just any questions about Istio. You should know that the majority of our engineers are listening to messages on those channels and are available to answer your questions. So great, Moz, I see you found this some of this information informative. I really appreciate you joining us, and hopefully it'll get you a little closer to working with a code base and getting over that hump, so to speak. It's not easy, but we can do it as a community. I should mention, if you work on a Mac with the new Apple Silicon chips that are ARM-based, this code compiles perfectly fine. But I am aware of the fact that maybe by default, some of the images that you fetch are not necessarily multi-architecture images. And so you might have to sort of fiddle with that a little bit, or there are certain flags that you might have to turn on to say, I don't want to build in a Docker image, I want to build locally on my machine. But you can definitely build and bring up all your code on a Mac with even on these new architectures. Some of the difficulty I've encountered is more in the sort of the packaging of Docker images. You want to make sure that you're packaging, again, multi-arch or ARM64 based images and not the x86 ones. All right, so we'll see you in a future episode. And again, thank you for joining.